Hello again. Some time ago I made a video on this Brymen BM27s pocket meter. This one happens to be sold by Amprobe. It's a part number PM55A. I'll leave the link to the original video in the description if you want to watch it. I'd purchased this meter after a member on the EEV blog site had posted how they had purchased some number of these. I think it was like 4 or 5 of them, and they all failed in the same manner. So I decided to buy one and see if I could cause the meter to fail in the same way. So this particular meter's been through a lot. I flexed it to the point where it almost cracked the meter. I mean, I'm really bending this thing. I've applied gasoline to the plastic parts. I've zapped it with my gas grill starter and later with my ESD gun. I've gone ahead and applied the 220 volt full wave rectified signal off of this transient generator while the meter was set to its various modes. And then I transient tested it some more using this homemade generator. Even with all that, it wasn't enough to permanently damage the meter. So you're probably wondering why the box is empty and whatever happened to the meter. Well, after I had made the original video, I decided I'd continue testing the meter. And what you're going to see in this video is all those tests. A lot of these will be tests that I've never ran on a handheld meter. So sit back and enjoy the video. Now you can see I have a couple of resistors. I'm just going to put these right across this battery, and we'll let that sit for a while and let it discharge the battery. Alright, let's check the output voltage. Let's see, so this is the Panasonic battery that came with the meter. You can see it's 2.7, and our Energizer battery is now 2.687. See, the battery's low enough now that the meter's just continually resetting. It's interesting. You can see the low battery indicator is not active. Looks like it's mode dependent. Let's see if we can get it to turn off. Comes right back on. Alright, so our meter's been cycling for the last couple of weeks. You'll notice now it doesn't turn on at all, so I'm assuming the battery's completely dead. Let's go ahead and we'll take this apart real quick. So recently somebody had commented on one of my videos where I had basically taken one of these little coin cells and I hooked it up to my transient generator, and then I applied a single transient with that generator, and of course the battery basically exploded. We ended up with quite a bit of flames and parts going everywhere. And somebody was pointing out that I shouldn't recharge these batteries, and they thought that my transient generator was actually a battery charger. I've got a holder here, it's not quite the right one, but I'm actually going to try to charge this thing up. Of course, these are not rechargeable batteries. I don't recommend anybody ever attempt this. So I'm just going to be using our bench power supply. We'll limit the current to a few milliamps. Let's just see what we got. So it's like about 1.2 milliamps, 1.3. Go ahead and look at the voltage across it. So about 3.3. I doubt this is enough to get that battery to do much of anything. Just let it sit like this for a little while and let's see what happens. So I'm not suggesting that True just didn't go out and buy a brand new set of batteries for the meter. What I'm wondering is if they maybe bought some of the rechargeables. Of course, those output a higher voltage than what these standard ones do. You know, maybe they over voltage the meter. I looked in the documentation, there's no specification as far as using the rechargeable batteries with it. Well, let's let it sit for a while. You can see it's been running a while and the current's dropped to about 0.8. Again, that's milliamps. Let's just slide this thing out of here. And let's see what we have for an output voltage now. Looks like about 2.73. Let's see, it's slowly dropping. Might be enough to allow this thing to fire up. Looks like it's too much of a load. This battery here is definitely officially dead. So again, this is the battery that the meter was supplied with. This is one that I had taken out of an old piece of test equipment I had. So let's just put the original battery back in. Oh, just heard it power up. Notice all the leaves. It's the middle of the fall. You see the meter powers up just fine. What I'm going to do is just leave this thing outside for a few days. I placed a bag over it because you can see we're getting quite a bit of rain lately. So I don't want it to get wet, but just put a light over it to hold it down in case we get some wind. Let's just see if this does anything to it. And you can see it's been a few days. Starting to see a little bit of snow. Let's just try to turn it on. Oh, it does turn on. Let's see, it's in auto mode. See if it'll turn back off. No problem. Well, we'll just let it continue to sit like this. You can see we have our first snow of the year. So buried under here. There you go. It's cold out. Oh. Powers up just fine. Let's see if it'll turn back off. Sure enough. Alright. Not the best thing for a meter, but there you go. Alright, so I'm just going to put this in the floor of the car. The reason is that I'm going to try to thermal cycle it. So during the night, the car will cool down quite a bit. It gets driven a couple times a day, so it should warm up real nicely. Hopefully it doesn't thermal shock the meter, but it might be more stressful to do this than just having it sit outside at a constant temperature. Alright, so I've had the meter in the car now for about a month, a little over a month actually. Let's see if it'll still power it up. Oh, the battery is definitely getting low. You can see it's starting to cycle now. Yeah, now I can't turn it off. Let's try a different mode. Oh, there we go. There, it's staying off. What I'll probably do is put this thing back outside now and let it sit for a couple more months. Alright, let's see if the meter will fire up inside okay. I've got some other tests I want to run on this thing before I take it outside again. You can see the battery indicator came on for a second. It's probably due for a new battery after sitting out in the cold like that for such a long time. Let's just do a real quick check. See how it's in low Z mode? I think that it's actually loading down my test box because this should be 5 volts. Let's just try it in the voltage mode. There you go, so 5.02. Let's just try it in AC. And this should be 2.5 volts. Looks good. Let's try resistance in the auto mode. So again, this will be 100 ohms. Looks fine. Let's try it at 1K. There you go, 1K ohm. Let's try it at 10. Looks good. And this will be 100K. And this will be 1 meg. And this will be 1 ohm. So I think I'm just going to leave the battery in here. There's a couple of tests, like I said, that I want to run on this. So I've been looking at all the meters that I have, trying to measure their battery lifetime. So I'm going to do that with this meter real quick, and then we'll take it back outside. And you can see the snow hasn't been real severe this year. Just put it back on our table. Make sure it doesn't blow away. Should be fine there. You can see we've had very little snow so far this year. Well, we'll let her set for a couple more months. You can see we've had quite a bit of snow. And here's the top of the lights. Here's our meter. We'll just take this inside and let it warm up. It looks like about a foot. That's what it's looking out on the deck with a little bit of light. You can see where the meter was sitting. And it's been out here for a couple of weeks. We'll go ahead and test it. Bag's a little wet still. And let's see if she'll turn on. Looks fine. Let's just try it with a single diode. So 0.6 volts. Let's place it into microamps. And again, this will be roughly 100 microamps. Looks fine. There's 10. That looks good. So no problems with that. Let's just try it with a 5 volt signal. 5.021. That looks good. Let's try it with AC. Again, this should be roughly 2.5. Oops. Looks good. Let's just try it in auto mode. Again, you can see the battery indicator is flashing. Let me just move the camera a little closer. There you go. So again, this is 5 volts. You can see the meter is selected low Z mode, so I'm sure that's loading down my test box. Let's just try it with a 1 mega ohm resistor. Looks fine. Here's 100K. Looks good. So it doesn't appear that the meter's having any problems. I've been meaning to change out this battery for some time, and I keep putting it off. Let's just go ahead and swap that thing out. So I first brought the meter in from the cold. I placed it on the kitchen counter, and it turned itself on after some time, and it happened to be in the auto mode, so it couldn't stay powered up, and then it would turn off, and it just started cycling, and it cycled like that for the day while I was at work, beeping on and off. So my wife was not too happy with me. I told her she could have just thrown the meter back outside, but she was a little concerned that she might do something with the test that I was running, so she just left it be. Alright, so one brand new battery. I'm sure putting a new battery in wouldn't have caused any problems, but we could go ahead and check it real quick. So again, this will be 100 ohm. Let's try it with a 50. Here's a 1K. Here's the 10K. Here's our 1 meg. Looks fine. Again, this will be 5 volts DC. And you can see it's still in the low Z mode. Let's just change it over to volts. And you can see 5.023. And again, this will be 2.5 volts AC. Let's change it over to auto mode. Let's see what it displays. 2.2 volts basically. Again, it's in low Z mode. And again, it's in diode check, so here's a single diode. Looks fine, 0.6 volts. Again, this is 100 microamps, and that looks fine. Come on, Tim. Weather's starting to warm up a little bit. You can see we have a little bit of rain coming down today. Yeah, I'll put a little bit of snow on this thing. Make sure it stays put. Well, this is nice and packy. There we go. Alright, we'll let it stay out here for a few more weeks and we'll test it again. You can see we've been having a lot of rain. Most of the snow is gone. Let's just turn it on. We'll see if it fires up. Oh yeah. There. Oh well. At least it still powers up. We'll continue to let it sit like this, I guess. You can see we're getting a little bit of snow today, not a whole lot. You can see weather's starting to warm up. We've lost quite a bit of our snow. We've been getting a fair amount of rain as well, you can see. Let's just try shorting out our leads. Continuity works just fine. Let's try it in the auto mode. Again, we'll short the leads out. Looks like it's still working fine. Typically what will happen is we'll get another big snowstorm sometime in the next month or so. So I'll just let the meter continue to sit out here. I'll check it again in a couple of weeks. Yeah, you can see there's only maybe about 1.25 inches or so left. Alright, it's been another couple of weeks. See, our snow is continuing to melt off. We haven't had a whole lot of rain lately. So the meter will turn on. No problems. Continuity seems to work. It looks fine. Alright, we'll go ahead and turn it back off. Let it sit for a few more weeks. Hey Tim, you liking the weather? Getting a little bit of snow today. see if our meter will fire up. Oh yeah. Definitely runs. Turns back off just fine. You can see we're getting a little bit of rain today. Tell you what, let's just take the meter inside and we'll check it out in there. It's getting to be spring. I still think we're going to get one more snowstorm before the year is up. Now let's have a look. Let's meter power up. It sure does. Let's just try our 1 mega ohm resistor. Looks pretty good. 10.01. This is our 100K. And here's our 10K. This is our 1K. And again, here's our 100 ohm. This will be with a short. Looks good. Let's put it in voltage mode. And this should be our 5 volt supply. That seems fine. Again, this should be 2.5 volts. That looks good. So again, this should be 2.5, except this is a averaging meter, so it's 2.5 times 1.11. That looks fine. Let's just try a diode check real quick. So again, this should be a single diode. Let's just switch it over to resistance, and again, this will be a 50 ohm resistor. Looks okay. And let's just try it in microamps while we've got the meter out. So again, this should be 100 microamps. Looks good. And here's 10. Looks fine. Well, we'll put it back in the bag and we'll stick it back outside. I understand we're supposed to get some big windstorms in the next few days. You can see almost all the snow is melted. There's a little bit out there, not a whole lot. We had some big windstorms the other day, so I moved the little table. See, we've got a little bit of snow. Not a whole lot. Let's just see if she'll turn on. Assume she's running okay. We're just now into March. They say we'll probably end up getting a couple of good storms yet in the next month or so. So I'll just leave it out here for a while longer. See, not a whole lot of snow. Maybe 2/10 of an inch today. We're getting close to spring. Come on, Tim. Let's go inside. You can see we've had a little more snow. It's been melting again over the last couple of days. It's actually warmed up quite a bit today. And you can see our meter fires up just fine. Come here. Hey, how are you? Alright, we'll give it a couple more weeks. So this is the first day of spring. The meter's been out here through the entire winter now, as well as part of the fall. Let's have a look here. Oh, sure enough, still fires up just fine. I'm just going to let it continue to sit up here for a little while longer. Alright, Tim, let's go inside. We've actually had a little bit of rain here today. When you know it, the camera batteries died, so I just decided to bring the meter back in. Let's go ahead and turn it on. This should be 100 microamps. See, it's reading 97.7. Looks good. This will be the diode check mode. Let's see, 0. It's in volts. Let's just try it with a single diode. See, it's still working fine. This will be a 100 ohm resistor. Again, this is a averaging meter, so this will be roughly 2.8. And this should read 0. And this should read 2.8 as well. And let's put it in auto mode. Let's just try it with our 1 mega ohm resistor. There you go. This will be our 100K. Looks good. This again will be our 50 ohm. Looks fine. This will be our 0.1 microfarad. It's about right, 102. It's pretty typical for most of the meters. Let's try the frequency mode. Again, this should be roughly 60 hertz. Looks fine, 59.8. This should be 30. Looks right. So I've been working on a new test fixture, and I plan to run this meter across it eventually. This is it here. You can see there's 4 speakers mounted to this piece of plexiglass. This is hooked up to a power amplifier. This is the interface to our vibration table. These 2 pins are the drive. These other 4 pins are for the LVDS. This is what's detecting the position of the plate. You can see the pin is located right in the center of the plate, and the sensor is located right there. You can just see it. Again, this provides positional feedback. Then I have some software written for this in LabVIEW. Originally, when I thought about vibrating this meter, this is what I started out with. So I just had a motor, and I strapped it to this piece of circuit board for a spring, and I was going to hook this up to the side of my desk with a C-clamp. Well, for now, we'll go ahead and take the meter back outside. Okay, we'll let our meter just sit out here, at least for the rest of the month. Well, it's been another week. Let's have a look. Meter runs just fine. You can see all the snow's melted. You can see today we have some freezing rain going on. It's starting to accumulate here a little bit. See, the meter fires up just fine. But I think I'm going to let it sit out here for the remainder of the day, or at least until this rain stops. Hey Tim, you can see we've gotten a little bit more snow. It's starting to accumulate. You can see it's coming down pretty good now. Yeah, you like that fresh air, don't you? Meter's starting to get covered up. Well, I think this is the end of our snow, so this is going to conclude my outside testing. Over this winter, we've had temperatures down to minus 20 degrees F, and we've had wind speeds up to about 50 miles per hour. As I mentioned originally, I thought about just using this motor attached to a section of circuit board to test the meter. You can see far out like this. You can see the natural resonant point is quite low, and as I move this in closer, see the frequency goes up. As you can see, let's just go ahead and move this in a little closer. problem with something like this again is that I wouldn't get reproducible results with it. So I was looking through the user's manual for this Fluke 189, and they actually call out a vibration standard, and it's mil-T-28800F. The specification supersedes the T, and if we look on page number 52 in the Fluke manual, they refer to it as a class 2, and you can see we have frequency increments in hertz, 5 to 15, 16 to 25, and 26 to 55, and then they give a displacement in millimeters peak to peak, and they start off at 1.5, 1.0, and 0.5. They also have a random vibration profile. So I'm going to deviate from this a little bit. I'll start off at 5 Hertz, and I'll step all the way up to 15, and I'll keep that displacement at 1.5, and then I'll go from 16 to 25 at 1.0 and work my way up. So I'll sweep from 5 to 55 Hertz, and then back to 5 Hertz, and I'll do that over a course of an hour, and then I'll repeat that cycle 3 times. So I'm not going to record this whole event. Again, this will be over the course of several hours. And assuming the meter still works, I'm going to run a log sweep over a much wider frequency range. Again, this is at roughly 1.5 millimeters of displacement, and the way I set that up is I just use this dial indicator. Alright, we're currently at 21 Hertz, it looks like. So what I do is just get my other camera out, and we'll take some high-speed footage of what the cables look like where they're coming out of the meter here. Frequency is now about 46 Hertz, so even though the displacement is quite a bit less right now, you can see on our software it's roughly 0.5 millimeters. The volume is quite a bit louder than what we had at 1.5 millimeters. Meter's been cycling continuously now for about 2.5 hours. Has about another half an hour before it completes. I don't see any visible signs of any problems with it. The cycle testing is just finishing up. Looks like it's about 7.6 Hertz right now. So I started our second phase of vibration testing. This is a logarithmic sweep from 10 Hertz to 150 Hertz. Again, that takes place over 60 minutes, and again we'll be running 3 cycles. So I start off with a 1.5 millimeter displacement, and it'll run that way up to 15 Hertz, and it'll roll off linearly up to 150 Hertz. It's currently set for 500 samples per decade. For those of you that watch this channel, you probably remember me buying a cheap analog meter. I set that meter up on this test jig, and I ran these same sweeps, and unfortunately I damaged that meter. You can hear the frequency slowly ramping up. Again, this is going to go up to 150 Hertz. System's just up to 150 Hertz. You can hear it starting to slowly decrease the frequency now. I don't really see any points where this thing's resonating, but it's not like the mechanical meter. You could definitely see the needle on that meter starting to deflect as it would go in and out of resonance. Alright, so it's been several hours. It's hard to believe the meter would see anything worse than that sitting in the glove box of a car, but let's have a look. Turn on. Does seem to. Yeah, let's try our 1 mega ohm resistor. Looks good. This will be 100K. Looks fine. This will be 10K. Looks good. Here's our 1K. Looks good. This will be roughly 2.5 volts. You can see it's in the low Z mode. Let's try it with 5 volts DC. Again, it's in the low Z mode, so it's loading down the meter. Let's just switch it over to volts. There you go, 5 volts, and let's try it with AC. And you can see it's 2.5 volts. And we'll put her into AC mode. Again, this will be 2.8 or so. Again, it's an averaging meter. And diode check mode. Again, this will be a short. Looks fine. Let's just try it with our 100 ohm resistor. Again, looks good, 102. And let's just try current real quick. And this will be roughly 100 microamps. Let's see, it's 97.7. So no worse for the wear, it looks like. I think this is going to conclude my second round of testing of the Brymen BM27s. One of the things that came up recently is somebody was asking me about vibration testing some meters that have potentiometers in them. Of course, I recycle all the meters that I damaged, but I happen to have a couple of circuit boards that did have some potentiometers on them. So I've gone ahead and mounted these to this circuit board. There's also a few capacitors. This potentiometer on the left is made by Borns. Actually, this one didn't come out of a handheld meter. This is the part that I used to replace the one in my UT61E. So I wrote down the value for all these pots, and then I set them all to their center position, and then I went ahead and measured the values. I did the same for the 3 capacitors. So what I plan to do next is some sort of vibration testing on the circuit board, basically to give an idea if these potentiometers are going to change. So another thing that's currently going on is I've started a new poll up on the EV blog site, and I'll provide a link for that in the description. Basically what I'm looking for is input on if we should continue running these tests or not. So if you'd like to see more handheld meters tested, just go ahead and give it a yes vote. Otherwise, give it a no. Again, I'm not affiliated with any of the companies that produce handheld meters. I don't have any kind of a store. There's nothing on this channel that's for sale. I don't have a Patreon account, and I normally won't accept any kind of donations. In a few rare cases, I've accepted meters from outside sources. Those meters were treated the same as any other meter, and also, to be clear, any bias that I have towards or against these meters really doesn't come into play. It's really how the meters perform against the transient generator, and of course this isn't really going to care what's connected to it. Again, it looks like the channel's continued to grow a little bit since my last video. I'd like to take this time to welcome all you new followers. Well, that's it for this video. Hope you enjoyed it. Till the next test. Later.